Hey everybody, in this video we are going to solve problem 1342, number of steps to reduce a number to zero. So we are given a number and then at each step, if the number is divisible by 2, we can divide it by 2. Otherwise we reduce 1. So these are the only possible steps or actions that we can apply on an input number. So we do it until we reach to 0. So for example, here, as you can see, 14, it is divisible by 2, or it is an even number. So at first step, we divide it by 2, so 7. Then 7 is not divisible. So when I subtract 1 from an odd number, it will be an even number. So then it's 6. Divisible by 2, so we divide it by 2, so 3. And 2, 1 until we get 0. Or in the second example, as you can see, 8. So we have 8 divided by 2, again divisible by 2 to 1. And so this is the last step, and then we have to subtract 1. So it took 4 steps to finally get to 0. So it is a very straightforward solution. So we can simply, one way is to implement it ourselves. The number of steps is equal to 0, and then while num is not equal to 0, if num is divisible by 2 equals 0, then num equals num divided by 2. So we are using this operation to make sure that the result of this division is always an integer, because initially num is an integer and we don't want to change the type of that. So otherwise, num we are subtracting 1 from the number, and then steps, we are adding a step and then return steps. This is one way, very straightforward. So as you can see, for 0 it works, and then for 8. Perfect. And lastly, the last test case, 14. And it is very fast, because at each step we are dividing the number by 2 or subtracting 1. So we are iterating through, it's a logarithmic algorithm. In the log n we can reach to 0. But the better way is similar to what we did in the last video in problem, what we did yesterday. So if you can see the numbers, if you consider them as binary numbers, for example 8, this is the binary representation of 8. So what's happening? Taking a look at the first bit, if it is 0, that means it is divisible by 2, so we are shifting that, removing that. Again, while the first bit is 0, we are shifting that. And then if it is 1, so that means it is an odd number, not an even. So we should subtract that. So whatever is before that, so let me show it again here. So we don't care what is before that. We have a 1 and then bunch of zeros. So for each 0, it takes 1 operation. But for 0, it takes 2 operations, because we should first subtract 1, and then it will be 0, and then shift it or remove it. So we can simply remember that in Python, without importing any library, we can convert a number, an integer number. We can obtain the binary representation of number in that number in a string format using a bin function. So let me for now return none, and then just print that. So as you can see here, we have a string. So it is starting with characters 0b, and then characters 110, which is the binary representation of 14. So if I go with 8, for example, same. So starting with 0b and then 100, but in binary format. So these are the characters in the string. So first of all, let's drop the first 2 characters that we don't want, in order to convert it from 0b something to, we are just removing these 2 first characters. So binary equals to this. And as we saw, each 1 bit takes 2 operations, and each 0 bit takes 1 operation. unless it is the very last iteration. So whenever we reach 0, so everything is 0, lastly, this 0 doesn't take any operation because we are not supposed to remove that because we are saying that for each 0 we are counting one operation except the very last one, because it is already 0, everything is gone, and then we don't have to apply anything, or we don't have to divide 0 by 2 again. So we can simply say the answer is binary that count zeros plus 2 times binary that count ones minus 1 because of the last operation that we just discussed. And this is the answer. Let's try the edge cases as well. Here we go. So, and we can simply implement that using the binary function that we did yesterday as well. So let me submit that. Perfect. So it has a problem was repeated a year ago or a few months back, but this was an easy problem again today, and hope you enjoyed it.